Hello and welcome you all in our next video. So in our previous classes we have seen some problems related to simultaneous linear equations, and we have seen some examples or some types of special types of questions, and here we have some other type of questions which can be framed from this chapter. So we are going to solve exercise questions of exercise 6, and question is question number 8. Okay, questions before 8 you can solve by yourself. We have already discussed concept related to that question. So 1 to 7 you can easily solve, and now we are going to discuss question number 8. Okay, so question 8 is: a man has certain notes of denominations rupee 20 and rupee 5 which amount to be rupee 380. If the number of notes of each kind is interchanged, they amount to 60 less as before. Find number of each denominations. So particular this problem is related to equation in two variables. Okay, here we have two unknowns, number of notes of rupee 20 and number of notes of rupee 5. We don't know the number of notes of rupee 20 and number of notes of rupee 5, but we know the amount that those two notes makes, that amount is 380. Okay, so condition 1 is that amount to be 380. Okay, suppose we have a pack of notes of rupee 20. Okay, so this pack contains x number of notes of rupee 20, and so first just assume the variables. Okay, so let number of notes of rupee 20 equal to x, and number of notes of rupee 5 equal to y. Okay, so we have here x number of rupee 20 notes and y number of rupee 5 note. Okay, assume this is a pack of rupee 20 notes each, and this pack contains x number of notes, and another pack, each note here is of rupee 20, and another pack we have of rupee 5. Okay, so another pack we have rupee 5 notes, and this pack contains y number of notes. Okay, so the total amount here will be 20 notes, x notes. Here total number of notes are x, so 20 into x plus 5 into y. So the total amount that will be equal to 20 into x plus 5 into y, and that amount is 380. Okay, so from condition 1 we can write 20 into x plus 5 into y equal to 380. This amount makes 380. Okay, so this amount is 380, so we will write this amount as 380. This is equation 1. Now we will try to find we are going to solve condition 2. Okay, so condition 2 here is if the number of notes of each kind is interchanged. Condition 2 is if the number of notes of each kind is interchanged, the amount to 60 less as before. So before the amount was 380. Now if number of notes is interchanged, means if this pack rupee 20 notes contains y number of notes, and this pack rupee 5 notes contains x number of notes, so this time the total amount here we will get that will be equal to 20y plus 5x, and this amount is 60 less as it was before. So before this amount was 380, and this time this amount will be 380 minus 60. That means this equation will be equal to 5x plus 20y, and that will be equal to 320. Okay, so this is our equation 2. From condition 1 we got equation 1, and from condition 2 we got equation 2. Now we have two equations in two variables, and we have to solve these equations. Okay, so here we can see that here we have 20x and here we have 5x, and if we want to eliminate this x, so here we must make 20. So to make here 20, we are going to multiply this whole equation 2 by 4. Okay, so I am going to write equation 2 multiplying with 4. Now multiplying equation multiplying equation 2 by 4. Okay, so if we multiply this equation 2 with 4, we will get 4 into 5, that is 20x, and here we will get 20 into 4, that is 80y, and here it will be 320 multiplied with 4. Okay, 320 into 4, that will be 0, 2 into 4, that is 8, and 3 into 4, that is 12. Okay, 1280. Assume this is equation 3. Now we have equation 1 and equation 3. So just we are going to eliminate this x. So write down equation 1 here below this. So equation 1 is 20x plus 5y equal to 380. Okay, equation 1. Now subtract equation 1 from equation 3. So if we subtract equation 1 from equation 3, this sign will be changed. Equation 1, this first is positive, so this will become negative. This second term is positive, so this will be negative, and this is the positive, so this will become negative. Now plus 20x minus 20x will get cancelled out. We will get 80 minus 5y, 80y minus 5y, that is 75y equal to 1280 minus 380. 1280 minus 80, that is 1200. 1200 minus 300, that is 900. Okay, so 75y equal to 900. That means y will be equal to 900 divided by 75. Okay, so 75, 25, if we cut it by the 25, so we'll get here 3, and here we will get 9 into 4. Okay, so if we again divide it with 3, so this will be 12. 3 here we will get 3 into 4, that is 12. Okay, so we got the value of y as 12. Okay, we got the value of y. Value of y is 12. And what we have assumed y is a number of notes of rupee 5. So that means for this particular question, the number of notes of rupee 5 will be 12, and we want to calculate the value of x. So put the value of y in equation 2. Now putting the value of y in equation 2, from equation 2, we will get 5x plus 20 into 12 equal to 320. So this will be 5x equal to 320 minus 12 into 20, 240. Okay, so this will be equal to 80. Okay, 5x equal to 80, that means x equal to 80 divided by 5. And here we will get a 16. Okay, so value of x is 16 and value of y we got as 12. So x is 12, x is 16 here, and the y value of y is 12 here. So for this particular question, number of notes of rupee 20 will be 16, and number of notes of rupee 5 will be 12. So 16 and 12 is the answer of this question. Okay, so you can solve other questions related to this type of notes and money problem. Okay, so you can try other questions if you have in exercise, okay, or in example. Try this type of all questions from your exercise and examples. Okay, so here we have another type of problem from exercise 6, and this problem is question number 26 from your exercise 6. Okay, so problem is, if A and B together can do a piece of work in 15 days, there are two persons A and B, and they both can together can do a work in 15 days. Okay, if A's 1 day work is 1.5 times the 1 day work of B, okay, find in how many days can each do the work. Okay, so question is related to time and work problem. So this is the time of and work problem, and you will get another problem from exercise 6 and in some questions in examples. Okay, so try to understand this concept clearly, and try to solve examples and other exercise questions with yourself. Okay, so question is A and B, there are two persons A and B, and both can do a work in 15 days. Suppose A can do a work in X number of days. Okay, let A, person A can do that work, can do the work in X days. A takes X number of days to finish the same work, okay, and B alone, and B can do the work in Y days. Okay, so alone A can do that work in X number of days, and alone B can do that work in Y number of days, and if they do together they can finish that work in 15 days. And here another condition is given, and condition 2 is if A's 1 day work is 1.5 times the 1 day work of B, find the how many days can each do the work. Okay, so we have to calculate the values of X and Y, and conditions here are given. Okay, first condition we have seen, first condition is A and B together can do a piece of work in 15 days. So here we have assumed A can do the work in X number of days. So what will be the, if A takes X number of days to finish a work, so what will be the work of A's in 1 day? You can write X days, in X days A do one work. Okay, one work. In X number of days A do one work, or A does. In X number of days A does one work. So what will be the work of A in 1 day, or 1 day work? 1 day, in 1 day. In 1 day A will do 1 upon X work. So total work is 1, and if we want to calculate the 1 day work of A, so that 1 day work will be 1 upon X work. Okay, so if we give X number of days to A, so that total work will become 1 by X into X, that is 1 work. Okay, so that work will finish in X number of days. So here we calculated 1 day work of A, and that work is 1 by X. Similarly, we can tell in 1 day, B will do 1 upon Y work, because B is doing same work in Y days. So Y days B do 1 work, so 1 day this will do 1 upon Y work. Okay, so here 1 day work of A is 1 by X, and 1 day work of B is 1 by Y, and total, and both, if they both work together, they can finish the same work in 15 days. Okay, so 15 days work of A. From here this is the 1 day work of A, so we can calculate 15 days of work, 15 days of work of A, and that will be equal to A 15 by X, and that work will be equal to 15 by X. Now 15 days work of B, 15 days of work of B, and this work will be 15 by 1 day work is 1 by Y, so 15 days work will be 15 multiplied with 1 day work, and that will be equal to 15 by Y. Okay, so 15 days work of A is 15 by X, and 15 days work of B is 15 by Y, and the total work, if they work together, the work is done in 15 days. That means 15 days, if X do 15 days work and Y do 15 days work, that total work is equal to 1 work. Okay, that means 15 by X, that means 15 by X plus 15 by Y will be equal to, this is 15 days work of A, and this is 15 days work of B, together do 1 work. That means this work will be equal to 1. Okay, so this is equation 1. This is equation 1. We translated from condition 1. Now condition 2 is if condition 2 is A's work, 1 day work is 1 by 2, 1.5 times the 1 day work of B. So we are going to translate equation condition 2 into algebraic expression. Okay, so 1 day work of A is 1 by X, 1 day work of X is 1 by X, and 1 day work of Y is 1 upon Y. okay. 1 day work of x is 1 upon x, and 1 day work of y b is 1 upon y, and this is the 1.5 times of this b's work, okay. That means 1 upon x is 1.5 times of this work, okay. So we are going to we are going to multiply this with this factor 2 into 1 plus 1, that means 3 by 2, okay. So this will be equal to 2y equal to 3x, or we can write here y as 3x by 2, okay. Y as 3x by 2. Now put this value of y in equation 1. We will get 15 by x plus 15 by y. In place of y I am going to write 3x by 2 equal to 1. Here this will get cancelled with 3 and we will get 5. So 15 by x plus 15 by x plus 2 into 5, 10. 10 by x will be equal to 1, and this, if we solve this, we will get 25 divided by x will be equal to 1. From here we will get x as 25. That means alone x will do the same work in 25 days, okay. Together they do that work in 15 days, but x alone, a alone do that work in 25 days, and it is obvious that time will be more than they do together, okay. Next we want to calculate how many days b will do that work. So put this value of x in this equation. So we will get the value of y as 3 by 2 into x, and the value of x is 25, and this will be equal to 75 divided by 2, okay. So this will be equal to 37 and half, okay. So b will do that work in 37 and half days. Okay, so here we have another type of problem, and this problem is related to time and distance, and is related to speed and time question, okay. So this problem is particular time and speed problem, and question is 28th question from exercise 6. And question is, a train covered a certain distance at a uniform speed. Okay, certain distance means the train is running between two particular places, and that distance is constant for this particular question. And question is, a train covered a certain distance at a uniform speed if the train had been 30 km per hour faster. Means actual speed of train is not changing, but it is it is being said that if a speed of train is 30 km per hour faster, it would have taken 2 hours less. Okay, so the time taken by time would have been less than 2 hours, okay. And the condition 2 is if the train was slower by 15 km per hour, okay. Condition 2 is if train runs slower than actual 15 km per hour than its actual speed, it would have been 2 hours more than the scheduled time. So a train will take 2 hours more than the scheduled time. Find the length of the journey, okay. Suppose speed of the train, okay. Suppose speed of train, let speed of the train as x equal to x km per hour, and the time taken by this train, okay, time taken by the train is y equal to y hour, okay. So what will be the distance if speed is x and the time taken is y? What will be the distance between two stations that this train is covering, okay. So we have learned in our previous classes a formula of speed. We all know that speed is equal to a distance divided by time. Distance divided by time, okay. So this was the this is the formula which we have studied in our previous classes, 7th, 6th or 5th, okay. So we all know speed is equal to distance by time, or we can write distance if we want to calculate distance. So distance will be equal to speed into time. speed into a time. Okay, so this is a distance equal to speed into a time. Okay, so the actual speed of train is x and the actual time taken by the train is y. So we can calculate the distance, and that distance will be distance d will be equal to speed of train is x and time taken by the train is y. So the distance of distance covered by this train is equal to x into y, that is xy. For both two conditions, one thing is not changing, and that one thing is a distance. Okay, first in condition 1, speed is increased by 30 and time is reduced by 2 hours. Distance is not changing. And in condition 2, speed is decreased by 15 and time is increased by 2 and distance is not changing. Okay, so we are going to use this formula for both two conditions. Okay, condition 1 is if the condition 1 starts here, if the train had been 30 km per hour faster, it would have taken 2 hours less than the scheduled time. Okay, condition 1 is, okay, speed of the train is x. We are going to increase the speed of train by 30. So the speed of the train will become x plus 30. And time taken by the train, it is saying that the distance is not changing and time is decreasing here by 2 hours. Okay, so the time will become y minus 2 equal to this distance, this speed into time. What gives us distance into this speed into time? What gives us speed into time gives us distance. So this is the actual distance between two places, and that is not changing, and that distance is equal to xy. Okay, so this distance will be equal to xy. Now solve this algebraic expression. We will get x into y, that is xy, plus y into 30, 30y, minus 2 into x, minus 2x, minus 2 into 30, minus 60, and this will be equal to xy. Okay, this xy and xy term will get cancelled out from both sides, and we will get equation as 2x minus 30y equal to minus 60. So from condition 1 we got equation 1. Okay, and condition 2 here is if the train was slower by 15 km, this time we are going to decrease the speed of the train, and actual speed is x, and if we decrease it by 15, so the speed will become x minus 15. Now the train is taking 2 hours more, that means actual time taken by the train is y, and if we are going to decrease the speed, time taken by the train will be higher, and that higher time is y plus 2. And if we multiply speed with time, that will be equal to distance, and for this particular question distance is not changing, distance will be equal to xy. Solve this particular algebraic equation. We will get x into y, xy, minus 15 into y, that is 15y, 2 into x plus 2x, 2 into minus 15 minus 30, and this will be equal to xy. Xy and xy gets cancelled out from both sides. Finally we will get 2x minus 15y equal to 30. So this is our equation 2. From condition 1 we translated condition 1 in algebraic equation 1, and condition 2 we translated condition 2 into algebraic expression equation 2. Now solve equation 1 and equation 2 either by elimination or by substitution. So here we can see here it is 2x, here it is minus 30y. We can easily eliminate this 2x term, or we can eliminate y term. Okay, so I am going to subtract equation 2 in equation 1 in equation 2. Okay, so subtracting equation 2 in equation 1. Now I am going to subtract equation 1 in equation 2. So I am going to do equation 2 minus equation 1. So we will get equation 2 is 2x minus 15y equal to 30, and equation 1 is 2x minus 30y equal to minus 60. Okay, so this is our equation 2 and this is our equation 1. We are going to subtract equation 1, so sign change will take place. Minus plus 2x will become minus 2x, and this minus 30y will become plus 30y, and this minus 60 will become 60. Okay, now plus 2x and minus 2x will get cancelled out. Here we will get 30y minus 15y, that is 15y, and here we will get 60 plus 30, that is 90. Okay, so the value of y will be so we will get the value of y as 90 by 15, and here we will get 6y as 6 hours. Okay, so the value of y is 6, and we assumed in the question y is the time taken by the train, and for this question time taken of the by the train will be 6 hours. We want to calculate value of x. Put the this value x equal to 6 in this equation. So we will get the value of x as 2x minus 15 into 6, 15 into 6 equal to 30. Okay, so this 2x will be equal to 15 into 6, 90, and 90 plus 30 will be 120. So x will be, from here we will get the value of x as 60. Okay, so the speed of train will be 60 kilometer per hour. Speed, we got speed at 60 kilometer per hour, and time taken by the train is 6 hours. So distance covered by this train will be equal to x into y, and that will be equal to 60 into 6, that is 360 kilometer. Okay, so for this particular question, distance covered by the train is 360 kilometer. Okay, so solve all the questions in your exercise and in examples which is related to speed and time. Okay, solve all the questions related to this concept, and if you have any other query or any other doubt in any questions, we have covered all type of concepts related to this particular chapter, and if any concept is remaining, you can just send your query or your question through a message. Okay, and I will try to clear your doubt. Okay, thank you. We will meet in our next video. Thank you.